Hi everyone. In the last lecture we have seen about trusses, which is very important because in engineering mechanics it carries 5 marks. Uh, in those 5 marks, 2 to 3 marks will be from trusses only. And today let us discuss about the friction. So friction questions will not be directly asked in GATE, but in work energy principle and D'Alembert's principle, this friction questions are asked indirectly. So let us see the basics of friction. So what is frictional force? A resisting force on a moving body by small projections of the surface on which body is moving is called frictional force. So if a body is present on a surface, if there is a body and this surface has small projections, in some cases those are visible to eye and in some cases those are not visible. If we apply a force on this body, if we apply a force P and up to some extent, up to some maximum force P, this body stays at rest only, because we have seen in second law of motion that if any force is applied, the body should move with acceleration a mass of body m should move with acceleration a. But in reality, if a force is applied, this body is not moving up to some maximum value p. So why it is not moving? Because a resistive force of the surface is applied on this body, and that resistive force is called frictional force. And it is to be noted that frictional force is an adjusting force, which means if a force, if this maximum force, let it be 10 newtons, 10 newtons for a body resting on a surface. If we apply 1 newton force, then frictional force will be 1 newton. If we apply 2 newtons, frictional force will be 2 newtons, which means up to 10 newtons the frictional force will be applied, which is equal to the force applied. That is adjusting force. So frictional force is an adjusting force. Based on rest and motion, friction is divided into two types. One is static friction and another is dynamic friction. Static friction is the one in which body is at rest. Friction acting on bodies at rest is called static friction. We have seen in this example that the body is staying at rest up to some point. In this case it is 10 newtons. Up to this point the body stays at rest only. The frictional force which is acting in this condition is called static friction. There is a body here, there is a surface, and this is a body. A force is applied and frictional force is applied by the surface in the opposite direction to the direction of motion. So it is static friction. If the body is in motion, frictional force applied on the bodies in motion is called dynamic friction. The bodies can be moved in two types. One is to slide on the surface and to roll on the surface. To slide on the surface means this is the surface and this is the body. The force is applied here and it is moving with some acceleration a. There is frictional force applied. So this is sliding friction. The bodies can also move by rolling. Suppose there is a ball here and it is rolling. So a ball can be slided, or it can be rolled. The friction acting when the body is rolling is called rolling friction. The friction acting when the body is sliding is called rolling friction. In rolling, if there is a point here, after rolling certain distance, this point reaches somewhere here. But in case of sliding, if there is a point here, after sliding certain distance, it remains at the same position. This is the difference between sliding and rolling. So in considering experimenting all these frictions, rolling friction is of less magnitude when compared with sliding friction and when compared with limiting friction. So what is this limiting friction? We have seen that up to a maximum value of P, the body stays at rest. So this maximum value of P, at this maximum value of P, for which a frictional force is applied, which is called limiting friction. Limiting friction is at maximum value of P at rest. That is called limiting friction. So it is experimentally found that magnitude of limiting friction bears a constant ratio to normal reaction. It is called coefficient of friction. So what is normal reaction? Let us see what is normal reaction. Every body has a weight. Matter has mass, and every mass attracted has gravity, so that it has weight. So every body has a weight. If a body is resting on a surface, and the body weight is W, the surface exists a reaction N, which is equal to the weight of the body. The surface exists reaction which is equal to W, and this direction is perpendicular to the surface. Direction of normal reaction is perpendicular to the surface. So what is this experiment is saying? Magnitude of limiting friction bears a constant ratio to normal reaction. The magnitude of limiting friction is, suppose in here it is say F. A force P is applied here, and F is the frictional force acting on this body by the surface. So F divided by N is equal to constant. This is what the experiment is saying. F divided by N is equal to constant, and this constant is equal to coefficient of friction, which is represented by mu. This is the equation. Mu is equal to F by N, and it is also defined as the angle made by the normal reaction and resultant of friction and normal reaction is called angle of friction. So what is angle of friction? Angle of friction is angle made by normal reaction. angle made by normal reaction, and resultant of normal reaction, resultant of normal reaction and frictional force. We can see here that normal reaction is this and frictional force is this. The resultant of frictional force and normal reaction is, say here, it is R. Angle made by normal reaction, which is this vertical line, and the resultant of normal reaction and friction is this green line. So the angle between these two forces is theta, and it is called angle of friction. From this triangle we can see that tan theta is given by F divided by N. Opposite side divided by adjacent side is tangent of any angle. So tan theta is equal to F by N, which is equal to F by N is equal to coefficient of friction, which is found experimentally. So tan theta is equal to mu. Here where F is limiting friction, and N is normal reaction. Theta is angle of friction. So a surface which is very rough has coefficient of friction high value, and a surface which is smooth has low coefficient of friction value. So let us see inclined planes. In inclined planes, a term generally used as angle of repose or slip angle, which means if there is a small inclination and a body is staying on this inclined plane and the body is not sliding down, if some angle is increased and the body is not sliding down yet, at particular instance, at particular angle, if the body starts sliding down, this angle at which the body starts sliding down is called angle of repose or slip angle. So let us see the definition of angle of repose. The minimum inclination of the plane on which a body free from external forces can repose is called angle of repose. We can see from the explanation that there is no external force applied, but this body is sliding down due to the gravity, and it is overcoming the friction and it is traveling down. So this angle of repose travels without any, if the inclination plane is at the angle of repose, the body travels without any external forces are applied on this body. This angle of repose is represented with phi. So let us see the analyzation of this angle of repose. This is angle phi, and this is weight W, weight of the body which is acting downwards, and it has it has components perpendicular to the plane, perpendicular to the inclined plane, and parallel to the inclined plane. This is the angle phi, which is equal to angle of repose. So how did we get that angle equal? This is the inclined plane, right? Transfer these forces up to here. So this is W, perpendicular to the plane. This is this. So this is angle phi. This is 90 degrees. This will be 90 minus 5, because this is 90 minus 5 is 90 minus 5, and suppose this is angle x. So sum of angles in a triangle is 180 degrees. So x plus 90 minus 5 is one angle, and another angle is 90 degrees, which is equal to sum of angles in a triangle is 180 degrees. So x plus 90 plus 90 is 180, minus 5 is equal to 180 degrees. 180 180 gets cancelled, and x is equal to 5. So this angle is 5. This is how we got 5 here. If this is 5, this one will be W cos alpha, because it is adjacent to the hypotenuse, and this is W sin phi, which is opposite to the hypotenuse. And we have seen that every body exerts weight on the surface, and every surface exerts normal reaction on the body, which is perpendicular to the surface. And this is the surface. Perpendicular to the surface is this in this direction, so it exerts normal reaction N. In angle of repose, we have seen that at angle of repose the body just starts sliding down, which means motion is in this direction. So frictional force acts opposite to the motion of the body, and that's why frictional force is acting upward. And if we compare the forces perpendicular to the inclined plane, which are N and W cos alpha, so these are equal. N is equal to W cos alpha, because these both are in opposite directions, and forces parallel to the inclined plane, which are frictional force and W sin alpha. So F is equal to W sin alpha, which are opposite in direction. So if we say N is equal to W cos alpha as equation 1, and F is equal to W sin alpha is equation 2, dividing 2 by 1, we get W sin alpha by W cos alpha. So W sin alpha by W cos alpha, which is F by N, Here W gets cancelled, and sin phi by cos phi becomes tan phi. So here phi is angle of repose. We have got here that tan phi is equal to F by N, and we have seen in angle of friction that F by N is coefficient of friction, which is equal to tan alpha. And from this we can say that at angle of repose this phi is equal to alpha, which means If we find angle of friction, we can say that if the angle of friction is some 20 degrees for a body and a surface, by constructing a by constructing an inclined plane by constructing an inclined plane at 20 degrees, the body starts sliding down. This is what it is representing. So at angle of repose, phi is equal to alpha, which means angle of repose is equal to angle of friction. So next is cone of friction. What is cone of friction? The inverted cone generated by gradually changing the direction of P through 360 degrees is called cone of friction. So what generates this cone is the resultant generates the cone. If we see here, there is a body on a surface, and if I draw a top view, and this is the top view, let us say first force is applied here in this direction, and next here, next. Likewise, if 360 degrees is applied here, 360 degrees, for every force, for every directional force P, there will be formed a resultant and the normal reaction. This is the normal reaction, this will be normal reaction, and there will be resultant. So if a force is applied in this direction, which means at 180 degrees, the resultant force will be in this direction. So for every force in the 360 degrees, if we plot the resultant and for normal reaction, a cone will be formed like this, and the angle subtended by resultant and normal reaction will be alpha, which is angle of friction. So the cone will have a semi-central angle equal to alpha. So the angle of cone will be 2 alpha, and semi-central angle, which is half of the angle of cone, is alpha. And another important one is rope friction. In transferring the power, the pulleys and ropes are used. Ropes or belts. While transferring it, the friction plays a very important role. Because of the friction only, the power is transmitted here. So if you see here, the pulley is rotating in anti-clockwise direction, and these are the tensions T2 and T1. If you see here, we have seen that frictional force acts in a direction opposite to the direction of motion. So this is the direction of motion of pulley, and frictional force acts opposite to the direction of motion of pulley. So this T2 is equal to T1 plus F, which means T2 is greater than T1. Here T2 is greater than T1, and the side T2 is called tight side, and side T1 is called slack side. tight side is the one in which tension is more, and slack side is the one in which tension is less. If the pulley and rope, here the pulley is the surface and rope is the body, if these two have coefficient of friction mu, and the angle of contact, what is angle of contact? Angle of contact is theta. So if the angle of contact is theta, which means the rope is see here, the rope is wound from this point to this point, which means the rope is touching the pulley from here to here, and the angle made at the center by this rope which is contacting on this pulley is theta, and this theta is not the angle of friction. Alpha is the angle of friction, theta is angle of contact, and phi is angle of repose. Up to friction, remember this is angle of friction, this is contact angle, and this is angle of repose. So the tight side tension T2 is equal to T1 into e power mu theta. So T2 is T1 into e power mu theta, and if the rope is wound n times, which means there is a pulley like this and the rope is wound n times, this is 1 turn, 2 turn, 3 turn, 4 turn, and like this n turns, and this is angle theta. So T2 is equal to T1 into e power mu into 2 pi n. And this is, let us not say this is theta, this theta will be 2 pi n, where n is number of turns that is wounded on the pulley. So remember these two formulas. So T2 is equal to T1 e power mu theta. If it is wounded by n turns, then it will be T2 is equal to T1 into e power mu into 2 pi n. That will be the theta. So that's it for the friction. If you like this video, please share with your friends and subscribe to our channel.